EPFL Xplore is a student organization whose aim is to design and develop a rover from scratch to participate in one or two international competitions: the University Rover Challenge in the United States and the European Rover Challenge in Poland. This competition gives us 4 main tasks to achieve. A science task instructs the rover to collect soil samples and analyze those in situ in the scope of a biological or geological science plan formally defined by students. Following, an equipment servicing task assesses the agility of the rover's robotic arm, which will quickly manipulate small objects. An autonomous navigation task qualifies the ability of the rover to drive autonomously from one location to another and overcome the complexity of a rugged desertic terrain. And finally, a retrieval and delivery task requires the rover to collect a cache and deliver it to a given location. To accomplish this mission and respect the requirements that come with, we identified 6 subsystems which make the rover: electronics, software, science, control station, and link device and structure.
First of all, the control station subsystem deals with all the hardware and software linked with the rover-based communication, be it on the control station or on the rover. The structure subsystem's goal is to design a reliable chassis which should overcome all types of challenging terrains. Moreover, it has to ensure that all the modules of the other subsystems can be correctly integrated on the rover. Further, the handling device subsystem is expected to design a multiple degrees of freedom robotic arm for object manipulation and detection.
Then comes the science subsystem, whose goal is to ensure the successful completion of the science mission. It includes the software and hardware needed for the scientific experiment and the design of the experiment itself. Of course, all this wouldn't be possible without the electronic subsystem, which designs the onboard hardware and manages the power throughout the electronic modules. Controlling the behavior of the rover is the main role of the software subsystem. Using machine learning, it will have to create an autonomous navigation software that should compute the shortest and safest path through challenging terrains. These subsystems will be managed by team leaders in cooperation with system engineers to ensure a successful integration on the rover.
As an interdisciplinary project, EPFL Xplore is deeply rooted within the EPFL curriculum. Namely, it will give the students the opportunity to apply theoretical knowledge and learn not only through semester and master projects, but also during their free time to contribute to the success of the organization. Furthermore, this project will allow students to develop universal skills such as team building, teamwork, communication, problem solving, and leadership. The project will also allow students to find creative solutions to technical problems by developing their own design concepts and implement them on the rover. Finally, the strength of this project is based on its interdisciplinarity. 11 sections from 5 faculties, 10 laboratories from 4 faculties, and multiple external organizations will be involved.